There's an ancient principle that seems unbreakable. Something cannot come from nothing. It's common sense, right? In our everyday lives, everything we create requires materials, energy, and ingredients already present in our world. But here's where things get mind-bending. When we zoom out to a cosmic scale, we face perhaps the most profound question humanity has ever asked. How could our entire universe literally emerge from absolute nothingness? If you're fascinated by the deepest mysteries of existence and groundbreaking discoveries about reality itself, make sure to subscribe and hit that notification bell. You won't want to miss what we're about to explore today. And if this content gets your mind racing, show your support with a like.
It really helps us continue bringing you these incredible cosmic mysteries. Today, we're diving into the ultimate enigma. Where did everything come from? What do leading scientists say about this seemingly impossible question? And can we even answer it with our current understanding of physics? Let's find out together. Picture this. Billions of years from now, the universe reaches its end. Whether it's the Big Rip, the Big Crunch, or the heat death, scientists largely agree on one thing: our cosmos has an expiration date. The dominant theory suggests a cold, dark finale, where the last stars flicker out one by one, leaving behind an endless void of darkness. In this distant future, supermassive black holes will devour whatever matter remains, growing to unimaginable sizes before they too evaporate through a process called Hawking radiation. Space itself will continue expanding relentlessly, stretching out even the faint glow from these dying gravitational monsters until there's nothing left but cold, empty darkness. The universe will reach a state of maximum entropy, where all activity ceases completely. That's the mainstream view, at least. Most researchers consider this the final curtain call for our cosmic home. But here's where it gets interesting. Some brilliant minds see something completely different in this ending. They see a beginning, a radical idea. What if that cold, empty, lifeless universe isn't an ending at all? What if it's actually the perfect conditions for a new Big Bang? Some researchers are convinced that a dark, frozen, and utterly empty cosmos was exactly the state that preceded our own universe's birth. Before we explore this mind-blowing hypothesis further, we need to tackle another fundamental question. Where did the first physical matter actually come from? The origin of matter. When we talk about stable matter, atoms and molecules, it becomes clear that nothing like that existed during or immediately after the Big Bang. The early universe was far too hot and chaotic for complex structures to form. We know that the first atoms only assembled from simpler particles once conditions cooled enough to allow stable matter to exist. We also understand how these atoms later fused inside stars to create heavier elements. But none of this explains how something can emerge from absolutely nothing. Let's rewind the cosmic clock even further. Protons and neutrons, which together form atomic nuclei, are considered the first long-lived matter particles in galactic history. They formed shortly after the Big Bang. But before that, matter as we know it simply didn't exist.